Hey guys, today we'll be presenting the progress of our Project 2 and Project 3. This is Chaohao presenting. Current progress. We've basically completed Project 2. For Project 2, we did our quantization Python file and we compiled it to test the accuracy of our implementations. And the results showed that we had some minor issue to our results, but that's not going to be a problem. We'll show you what's the performance of our implementation in the later slides. For Project 3 pruning, we've already completed our trained model, which we took a week to train that. The pruning code was completed, and right now we're applying the pruning to trained model and get the curve of number of parameter against the accuracy. For Project 2, we were asked to convert the 32-bit floating point data into 8-bit fixed point format in order to improve the memory usage. And this almost assures that there will be a drop in our prediction accuracy, which we will show in the later slides. By running main.python, we got the quantized weight for our training, and the model we used was exception, and the dimension of the data was 1, 229, 229, and 3. And for quantization, to convert 32-bit float point into 8-bit fixed point format, the method we use is as following. First, we found out the mean in the equation, which is calculated by the fraction length and word length given. And then we take the original data minus that mean and divide it by the minimum quantization step, which we can calculate from the fraction length and word length input. And then we run that value up or down based on different situation. And finally, we add the mean, which we've already calculated, to it to get our quantized data. For our performance of the exception model, for the full word length, we got 75 correct predictions out of 100 input images, which equals an accuracy of 75%. And for our quantization result, we get an accuracy of 67%, which shows an 8% decrease for the accuracy. This is not the final result for our project, since we only use 100 images for testing. In the future, we'll be using a larger amount of data for testing our implementations and to get a better result. Now I'll pass it to Siyuan Zhao, and he will talk about Project 3.
Hi, I'm Siyuan Zhao, and I'm taking response for talking about Project 3. In the Project 3, with first step, we just training an original model from scratch based on dataset Cipher10, and this model without any pruning. And the dataset contained 15,000 training image and 10,000 testing images. And then we construct the structure for convolution neural network of exception and train this model with this dataset for 100 epoch, and bench number is 15,000, and then we train this model for about 3 days. And then after get the pre-trained model, according to the instruction, we find the prunable variables from the model that has been trained, and then pruning parameter based on the threshold, which is determined by the parameter percentage we set. This means, for example, n% pruning equal to the nth percentage of the parameter to be trainable, and then we get the the pruning gradient we want, and then we applied this utilize py files to the model and retrain and find the accuracy of the model after retrain. At present, I have just retrained several models with pruning percentage equal to 10%, 60%, 70%, 80%, and 90%, and 100% with the epoch as 10. And I get the accuracy of the training set, validation set, and the test set shown in this figure show above. So for the rough view of the current finger, the accuracy will slow down with the decrease of parameter. When the parameter of pruning is greater than 90%, we can see the accuracy will suddenly drop. And in the process of training, I also found that no matter how much a pruning percent is, the accuracy will increase with the increase of the epoch. For example, we see the pruning percentage is 60, and when the epoch 1, the accuracy is 0.873, while the epoch 10, the accuracy will go increase and at the 0.993. And here we can see in this graph, we just take the percentage, pruning percentage equals 60, for example. We found the accuracy of the training is very low at epoch 1, and then increase significantly at first, and then stable at the 0.993 is very equal to the 1. So so in the future work, I think in the following time we will keep working on the relationship between the number of parameter with the accuracy, and get a more accurate relationship, and then we will analyze the pruning results. And that we also will try our best to finish the quantization of the pruning model. This is all we done now, and we will keep going in the following time. Thank you.